Hello, this is Mrs. Ricard, and today we're going to talk about factoring trinomials where the leading coefficient is not 1. If you recall, before we were so rudely interrupted by the zombie apocalypse, we learned about factoring quadratic trinomials where the leading coefficient was 1. And in that case, we just needed to look at the constant, and we needed to find factors of the constant that when we did whatever the sign of the constant told us, either add or subtract, would give us the coefficient of the middle term, or the x term. But when you have a leading coefficient that isn't 1, it gets a bit more complicated. Now I know there's a lot of verbiage here, so let's look at it together. When we talked about multiplying trinomials, if you had 2 terms times 2 terms, so you have 2 binomials, you multiply the first terms together to get the leading term. You multiply the outer terms together and the inner terms together, and notice those both have the same x to the first power in them. And then to get the last term, you multiply the 2 last terms together. So when you combine the like terms that have the same power of x, you get the first term has a leading coefficient of d times e, and the last term has a coefficient of p times q, but the middle term is a combination of the d times the q and the p times the e. So what we're going to talk about is taking this process backwards, starting with something that looks like ax2+bx+c and breaking it down into the product of 2 binomials. Now, if you've already watched the videos that I assigned you on Khan Academy, they use a slightly different method for doing this. And there are many different methods, from guess and check to all kinds of things. But I'm going to show you a slightly different method for factoring these than the one on Khan Academy. You can use whichever method works best for you. So, if we want to express it as a product, we need to look for factors of the first term to figure out what numbers have to go at the beginnings of the 2 parentheses, and factors of the constant term that are going to give us the 2 at the end of the parentheses. But then when we combine those factors together by multiplying 1 times one of the first ones by one of the second ones, and then the other first one times the other second one, and combining together, they have to combine to make the middle term. So the first coefficient is the product of the numbers in front of the x's. The last coefficient is the product of the numbers at the ends of the 2 parentheses. So just like we had to look for factors the first time, we have to look for factors this time, but this time we're looking for factors of 2 different numbers. Now, that link is dead, so we won't even bother talking about it. It doesn't work anymore. So when you have a quadratic equation, the first thing you want to do is put it in standard form, which means in order from the highest power of x to the lowest. So ax2+bx+c. And then you have to look for factor pairs of not only the c, like we did before, but also of the a. And then we need to figure out, when we do the products, how are we going to get the absolute value of whatever b is when we do whatever the sign of c tells us to. Then we have to decide about the signs. And again, this is very similar to what we did when the leading coefficient was 1. If the c at the end is positive, that means the 2 products have the same sign, and you look at the sign of the middle number to figure out what sign to use. But if the c value is negative, it means the 2 products have to have, the 2 parentheses have to have different signs. and they have to subtract to give us the number in the middle. So whichever one the middle has, the bigger product, not just the bigger factor, but the bigger product of the outer two and the inner two would be the one that gets the sign of the middle. The hardest part of this is not finding the factors, but figuring out how the pairs either add or subtract to give us the middle. So here's how I do it. You can do this by grouping like the other one does, like the Khan Academy does, but I like this method. So when I have a quadratic equation, so not an equation, there's no equal sign, a quadratic expression, and it's in standard form, I'm going to start by making a little vertical line that's long enough for 2 rows of stuff. And I look at the first coefficient, and I'm put the factor pairs of that number on the left side of this line. So the only factor pairs of 2 are 1 and 2. Then I look at the constant term, and I put the factor pairs of that term on the right side of this little line. So the factor pairs of 6 are 1 and 6, or 2 and 3. Now, unlike when we factored with a leading coefficient of 1, where it didn't matter which set of parentheses we put the 2 numbers in, now it is going to make a difference. So we need to take into account all possible combinations. So I might not just be pairing 1 with the 1 and the 2 with the 6, I might be doing it the opposite order. So on one side of this, to take care of that, I'm going to write the factor pairs that I had in both orders. So since this had fewer pairs to rewrite, I just wrote that one. You don't have to do it on both sides, only one. So I call that the setup for this. So now we have to take one of these 2 numbers and multiply it by one of these 2 numbers with both pairs, and then in this case, since it has plus here, we're going to add those 2 products to see if we get 13. So when I multiply 2 times 1, that's 2. When I multiply 1 times 6, that's 6. 2 plus 6 is not 13. So the 2 and the 1 does not go with the 1 and the 6. Now I'm looking at the 2 and the 1 with the other pair over there. 2 times 2 is 4. 1 times 3 is 3. 4 plus 3 is not 13. Now I've paired the 2, 1 with both pairs over here, so it didn't work with either one of them. So I'm just going to cross that out because I'm not going to use it. And now I'm going to go to the 1 and the 2. 1 times 1 is 1. 6 times 2 is 12. 12 plus 1 is 13. So these 2 pairs are the pairs that you need to use to fill your parentheses. Once you've found one that works, you don't have to go on and try all the others. So now I'm going to write my 2 sets of parentheses that are big enough for 2 terms each. The 2 numbers from the left side go at the beginning of your 2 sets of parentheses. And whatever variable was squared here goes with them, but you're not squaring it. Now, when we multiply these out, to get the middle terms, this number would get multiplied by the one that goes over here, and this number would get multiplied by the one that goes over here. When I did these products, I did 1 times 1. So that means this 1 from the right side has to go over here so that it's multiplied by the 1x. And this 6 from the right side, since it was multiplied by the 2, has to go over here at the end of the first parentheses. Now I decide about the signs. Since this was positive, we know they have to have the same sign, and that means I just use the sign of the middle term for both sets of parentheses. So you don't have to write the 1 in front of the x. You could just write x minus 6 times 2x minus 1. If you multiply this out using FOIL, 1x times 2x is 2x squared. 1x times negative 1 is negative 1x. Negative 6 times 2x is negative 12x, and when you add the negative 1x to the negative 12x, that gives you the negative 13x in the middle. And then when you multiply the negative 6 times the negative 1, you get plus 6. So this is the factorization of 2x squared minus 13x plus 6. Going on to the second example. It's in standard form, highest to lowest powers already. So I'm going to put my little line big enough for 2 rows. Factors of the leading coefficient go on the left side. So the factors of 3 are 1 and 3. And that's only one set of factors for that one. For here, for the 4, I'm not even paying attention to the negative. I'm just pretending it's an absolute value, just plain 4. Factors of 4 are either 1 and 4 or 2 and 2. And that's all the factor pairs for 4. Now, remember, to make sure we get all the possibilities on one of the two sides, it doesn't matter which, we need to write the pairs that we have in both orders. I have fewer pairs over here, so I'm also going to write this as 3 and 1. So now, I multiply 3 times 1 is 3, 1 times 4 is 4. We want the numbers to subtract to give us 11. Well, 4 minus 3 is not 11, so we go on to the next one. 3 times 2 is 6, 1 times 2 is 2, 6 minus 2 is not 11. So the 3 and the 1 didn't work with either of the pairs on the right side. So now I go to the 1 and the 3. 1 times 1 is 1. 3 times 4 is 12. 12 minus 1 is 11. So these are the pairs that I need to use. The numbers from the left side go at the left side of each set of parentheses, with the variable that you started with, but not squared. The 1 on the left got multiplied by the 1 on the right. Well, when you multiply these, this number doesn't get multiplied by the 1 in the same parentheses with it. It gets multiplied by the 1 in the other parentheses, so you have to put it over there. And here, the 3 got multiplied by the 4, so the 4 has to go here. This is a subtraction sign this time. So since that number at the end is negative, that means these two numbers have to have opposite signs. And to decide which one gets the sign from the middle, we look at our outer and inner products. Well, 1 times 1 gives me 1, and 4 times 3 gives me 12. 12 is the bigger product. So the product that gives me 12 has to have the same sign as the middle. Well, I don't want to put a sign in front of the first terms, so here's where I need to put my plus sign so that when I multiply these I get positive 12n. And that means since they were different, this one has to have the minus. So this is the factorization of 3n squared plus 11n minus 4. If you want to check your work, you multiply it out using double distribution or FOIL. 1n times 3n is 3n squared. 1n times negative 1 is negative 1n. 4 times 3n is positive 12n. Positive 12n minus 1n gives me positive 11n. And 4 times negative 1 gives me negative 4. For this one, when you have a leading coefficient that's negative, the sign part gets confusing. So when I have a negative leading coefficient, the first thing I do is I factor out negative 1 from the whole thing. And all that does is change the signs of each of the terms. So this is going to be positive 3x squared plus 13x plus 4. and then I need to carry that -1 along when I go to do the factoring. But now I can ignore it and just look at the thing inside when I'm making my chart. So the factors of 3 go on the left, that's 1 and 3. The factors of 4 go on the right, that's 1 and 4, or 2 and 2. We need both orders on one side so that we get every possible combination, even if we had to switch them. And we're looking for the products that add up to 13. So far I've been doing this in a very orderly way to make sure I don't miss any possible combinations. But sometimes when you look at this set of numbers, you can tell right away one that's going to work. Because when I look at this, I see that 3 times 4 is 12, and 1 times 1 is 1, and that those are going to add up to 13. You just need to be a little careful about skipping around, because if you don't find it pretty quick, and you haven't gone in an orderly way, you might lose track of what you've tried and what you haven't. So, on the left side of my parentheses, I need a 3 and a 1. I'm not going to write the 1 this time because you don't have to write it, but you do have to put the variable with it. And I also need to remember that that -1 I factored out needs to be brought along with it. Now, the 3 was multiplied by the 4. So that means they can't be in the same parentheses together, so the 4 has to go over here. And the 1 was multiplied by the 1, so again, they can't be in the same parentheses, so that means the 1 has to go here. We're looking here because we still have the -1 factored out. This is positive, so that means both parentheses get the same sign as the middle. So these are both addition. So again, to check it, 3x times x is 3x squared. 3x times 4 is 12x, and 1 times x is 1x, so that adds up to 13x. 1 times 4 is 4, and then if you distribute the -1 through that, you get the original problem, -3x squared minus 13x minus 4. So there's lots of words here again, but it's just telling you the steps that I've been doing on those other problems. It's writing it out in words. So the problems that we did so far, there weren't a whole lot of factor pairs. There was only 1 on one side and 2 on the other side. But you can have problems that have a lot more factor pairs. So this example is one that has more factor pairs. It's already in standard form, highest to lowest power. So I'm going to draw my line tall enough for 2 rows. Now 12 has several factor pairs. 1 and 12, 2 and 6, or 3 and 4. 15 has a couple of factor pairs, 1 and 15, and 3 and 5. Now don't forget, once you've written the factor pairs, on one side you need to write it in both orders. So this side had fewer factor pairs, so I'm also going to write 15 and 1 and 5 and 3 on that side. Now I'm looking for products that subtract to give me 8. So when I start here, 3 times 1 is 3, 4 times 15 is 60. That's way too big to end up being 8 when you subtract them. 3 times 3 is 9. 4 times 5 is 20. 20 minus 9 is 11, not 8. 3 times 15 is 45. 4 times 1 is 4. That's only going to be 41, not 8. 3 times 5 is 15. 4 times 3 is 12. 15 minus 12 is 3, not 8. So the 3, 4 didn't work with any of them. Now I'm going to the 2, 6. 2 times 1 is 2. 6 times 15 is 90. 90 minus 2 isn't going to do it for us. 2 times 3 is 6. 6 times 5 is 30. 30 minus 6 does not give us 8. 2 times 15 gives us 30. 6 times 1 gives us 6. That's going to give us 24, not 8. 2 times 5 is 10. 6 times 3 is 18. 18 minus 10 is 8. So I took the 2 and the 6 times the 5 and the 3 to get my 8. So now I put my two sets of parentheses. The two numbers from the left side go at the beginnings of both sets of parentheses with whatever variable you were using, but not squared. The 2 was multiplied by the 5, so that means they cannot be in the same parentheses together because the things in the same parentheses do not get multiplied together. So that means the 5 has to go over here. The 6 got multiplied by the 3, so that means they can't be in the same parentheses, so the 3 has to be over here. Another way you can think of it is the ones diagonal from each other go in the same parentheses. Now we look at the sign of the constant. It was negative, so that means these two parentheses are going to get different signs, and the bigger product has to get the same sign as the middle, so the bigger product has to be positive. Well, our outer product is 10x, and our inner product is 18x. So since our inner product is bigger, we need to put the positive sign on the number here that makes that positive. You never want to put the sign in front of the first term, always in front of the second term. And since the signs were different, that means this one has to be subtraction. If we check it, 2x times 6x is 12x squared. 2x times negative 5 is negative 10x. 3 times 6x is positive 18x. When you combine 18 minus 10, you get positive 8x. And 3 times negative 5 is 15. So that is the factorization. Now, so far, let me just let you read that. And remember, if you print out these notes before you watch this video, it'll probably be a lot easier for you to do, and you can write it down, and that'll help you remember. Now, in the examples we did so far, it was just a quadratic expression. There was no equations, and there weren't any common factors involved. When you're factoring, you should always factor out a common factor first if there is one. So looking at this problem, first, notice there's an equal sign. So we have to get 0 on one side, just like we did when we had the quadratic polynomials with for leading coefficient of 1. You can't solve a problem that's factored unless the other side is 0. So the first thing I would do here is subtract 99 from both sides. So that gives me 6r squared minus 15r minus 99 equals 0. Now, before I start looking for factor pairs, I want to look at these three numbers to see if there's any number that divides into all three of them. Well, I know 3 goes into 6, and 3 goes into 15, and 3 goes into 99. I can't take anything bigger because the next thing would be like 6, but 6 doesn't go into 15. So the first thing I'm going to do after that is factor out the 3. So if I take 3 out of this, 6 divided by 3 leaves me with 2r squared. Negative 15 divided by 3 gives me minus 5r. And negative 99 divided by 3 leaves me negative 33. So now, since there's no other common factor than 1 to go into these, I'm going to make my little chart. I don't need to worry about the 3 except for including it in the end when I factor it. So factors of 2 are 1 and 2 on the left side. Factors of 33 are 1 and 33, or 3 and 11. That's it. Don't forget, on one side you need both orders. And now we're going to look for products that subtract to give us 5. 2 times 1 is 2. 1 times 33 is 33. 33 minus 2 is not 5. 2 times 3 is 6. 1 times 11 is 11. 11 minus 6 is 5. So I'm going to use the 2 and the 1 with the 3 and the 11. So the 2 and the 1 lead off the 2 parentheses with the variable r. So I get 2r here and just r there. Remember, that's the same as 1r. The 2 got multiplied by the 3, which means they can't be in the same parentheses, so the 3 has to go over here. The 1 got multiplied by the 11, so since this is where the 1 is, the 11 has to go here. Since the constant is negative, we get different signs, and the bigger product gets the same sign as the middle term. Well, the outer product is 6r, the inner product is 11r, so the inner product is bigger, which means this 11 has to get the same sign as the middle, and then this one's going to get the plus. Now, we were solving this. It was equal to 0. So, what we learned when we talked about the ones with a leading coefficient of 1 is if things that are multiplied together equal 0, that means one of those things had to be a 0. Well, 3 can't be 0. But 2x minus 11 can equal 0. And, sorry, I put x instead of r. And r plus 3 can equal 0. So we solve these two equations for their variable. So here, I'll do the easy one first. If you subtract 3, you get r equals 3. Here, first you would add 11 to get 2r equals 11. And then you would divide by 2. I know my writings get a little tiny there. So I get r equals 11 halves. And these two numbers are the solutions to this equation, which means if you replace r with 3 and multiply this out, both sides will come out to 99. If you replace r with 11 halves and multiply this out, both sides will come out to 99. In this example, again, we need to get it in standard form. So I need to subtract the 22z from both sides to get 0 on one side. Negative 22z. So that gives us 56z squared minus 22z plus 2 equals 0. Looking at these terms, so this is a 2, so the biggest number that can go into that is 2, and since these are both even, that means we can factor out a 2. 2 goes into 56 28 times, that's 28z squared. 2 goes into negative 22, negative 11 times, so we get minus 11z, and 2 goes into 2 once. So now I would make my chart, but there's a little bit of a trick here. Remember when we had a leading coefficient of 1, we only had to look at factors of the constant term? Well, when we have a constant term that's 1, we only need to think about factors of the leading coefficient. We still are going to use the sign of the constant to decide whether to add or subtract, though. So I'm going to have the 2. And at the end of both parentheses, I'm going to have a 1. And I'm looking for factors of 28 that add up to 11. Well, the factors of 28 are 1 and 28. Those don't add up to 11. 2 and 14 don't add up to 11, or 4 and 7, which do add up to 11. So since these are the same, it doesn't matter whether I put the 4 here and the 7 here or vice versa. So I put the 4 and the 7 at the fronts of the parentheses with the variable but not squared. And now for the signs. The plus on the sign of the constant means these two get the same sign, and the sign they get is the same as the middle one, so these are both minuses. Now it's factored, so I can set each factor equal to 0. Well, 2 can never equal 0, so I don't need to worry about that one. 4z minus 1 can equal 0, and 7z minus 1 can also equal 0. So for this problem, first I would add 1, and then I would divide by 4. So that would give me z equals 1/4. I'm going to write it up here where you can see it a little better. Here, first I would add 1, so that gives me 7z equals 1. And then I would have to divide by 7, so that gives me z equals 1/7. For the last non-word example, if you're solving the equation, when you have powers higher than 1, you have to get 0 on one side first. So I'm going to subtract the 20 from both sides. That gives me 30x squared plus 25x minus 20 equals 0. Remember that it's important that the terms go from highest power to lowest. Looking at these three numbers, they are all multiples of 5. And that's the biggest thing that they're all multiples of. You always want to take out the greatest common factor. So when I divide that out of 30, I get 6x squared. When I divide it out of the 25, I get plus 5x. And when I divide it out of the negative 20, I get minus 4. Now, we don't have a 1 on either end, so I'm going to make the chart. Factors of 6 are 1 and 6, or 2 and 3. Factors of 4 are 1 and 4, or 2 and 2. Now, we need to do both orders on one side, and both sides have the same number of pairs. But 2 and 2, no matter if you switch them, are the same. So I'm going to rewrite this side in both orders because I don't have to rewrite 2 and 2. So I need to carry my 5 along, and then I have my 2 sets of parentheses. So I'm looking for products that subtract to give me 5. 2 times 1 is 2, 3 times 4 is 12, 12 minus 2 is not 5. 2 times 2 is 4, 3 times 2 is 6, 6 minus 4 is not 5. 2 times 4 is 8, 3 times 1 is 3, 8 minus 3 is 5. So I'm using the 2 and the 3 with the 4 and the 1. So the parentheses have to start with the 2 and the 3, with the variable not squared. The 2 got multiplied by the 4, so that means the 4 can't be in the same parentheses with the 2. It has to be over here with the 3 at the end. And the 3 got multiplied by the 1, so the 1 has to be over here in the other parentheses. This was negative, so that means these are going to have different signs. And they add to make a positive in the middle, so that means the bigger product has to get the positive sign. So our inner product is 3x, and our outer product is 8x. The outer product is bigger, so to make it come out positive, I have to put the plus over here on the 4, and the minus is going to go on the 2x minus 1. So now I set each factor equal to 0. 5 never equals 0, so I don't have to worry about it. There's no x with it, I don't have to deal with it. But if 2x minus 1 equals 0, then we add 1, and that gives us 2x equals 1, and then we divide by 2, and we get x equals 1/2. If 3x plus 4 equals 0, we'd have to subtract the 4 first, and that gives us 3x equals -4, and then we'd have to divide by the 3, and we get x equals -4/3. So our solutions are x equals 1/2 or x equals -4/3. Now finally, let's take a look at our word problem. A rectangle's length is 5 feet more than 4 times the width. The area is 6 square feet. What is the width? Well, when you have a word problem that's describing a picture of something, a rectangle in this case, it's a good idea to start by drawing the picture. So this is a rectangle. It's talking about its length and width. Well, we usually call length the longer side. And they're asking, what is the width? Well, that means my variable has to be the width. So I'm going to call this side W. It says the length is 5 feet more than 4 times the width. So that means if I multiply W times 4, I have to add 5 feet more in order to get the length. So this is my width and length for this rectangle. It tells me that the area is 6 square feet. Well, the area of a rectangle is length times width. So 6 is the area, the length is 4W plus 5, and the width is W. Now, this may not look like a quadratic equation to you yet, because there's no squared term in it. But that's why we need to multiply this out. Now, don't get fooled into thinking that this is factored, so I just have to set these equal to 0, because this isn't 0, so that won't work. So when I multiply it out, 4W times W is 4W squared, and 5 times W gives me plus 5W. Now you can see that it is a quadratic equation because it has the W squared. I have to get 0 on one side, so I'm going to subtract 6 from both sides. That gives me 0 equals 4W squared plus 5W minus 6. Now that we have 0 on one side, we're ready to factor. So I'm going to draw my line. Factors of 4 go on the left side, so that's 1 and 4, or 2 and 2. Factors of 6 go on the right side, so that's 1 and 6, or 2 and 3. I need both orders on one side. Since this one has a repeated one, I don't have to write that in both orders, so I'm just going to write the 4 and 1 over here. And now I'm looking for products that subtract to give me 5. So 4 times 1 is 4, 1 times 6 is 6, 6 minus 4 isn't 5. 4 times 2 is 8, 1 times 3 is 3, 8 minus 3 is 5. So I don't even have to bother checking these other ones because I found one that works. There weren't any common factors in this, so I didn't have to do that first, but always remember to check for that before you start factoring like this. So now I have 0 equals, and I have my 2 sets of parentheses. The 4 and the 1 have to start off my parentheses, and remember you don't have to write the 1 because it's going to be in front of the variable, which in this case was W. It doesn't matter if you write the 4 here and the 1 here, or the 4 here and the 1 here, but then it does matter which number here goes with which number in your parentheses. The 4 got multiplied by the 2, so that means they can't be in the same parentheses, so that means the 2 has to be over here. The 1 got multiplied by the 3, so they can't be in the same parentheses, so that means the 3 has to be here. The constant was negative, so that means these two things have to get different signs. And the bigger product has to have the positive sign. So our products here are 8W and 3W. 8W is my bigger product. To make that term come out positive, I have to put the plus on the 2. And since the signs were different, that means you get a minus on the 3. Now that it's factored and equal to 0, I set each factor equal to 0. Here I have to add 3 to get 4w equals 3, and then divide by 4 to get w equals 3/4. Here I'd subtract 2 to get w equals -2. But w is a width, and a width is a measurement of length, and lengths can't be negative. So we have to throw out the -2 answer, and the width is 3/4. And since our measurements were in feet, this would be also in feet. This problem did not ask you for the length, but if they did ask you for the length, you could now go up here to where you had length in terms of width and plug in the numbers. So 4 times 3/4 plus 5. Well, 4 times 3/4, the 4's just cancel. That leaves you 3 plus 5, which is 8. So if they asked you, the length would be 8 feet. Okay, thanks for watching, and I will talk to you soon.